Good morning, good afternoon, and good evening. Dear authors and distinguished guests, welcome to Technical Session 9B. I'm Sanskriti and I will be moderating this session today. On behalf of the Global Knowledge Research Foundation and GR Scholastic, it is my pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, that is ICTIS 2026, being hosted in Bangkok, Thailand. This 11th edition is being conducted in a hybrid mode. The virtual sessions are being conducted via Zoom from 9th to 11th April 2026. I hope you find today's session insightful, engaging, and intellectually enriching. In this session, we have 10 presentations. Each presenter will have 10 minutes for their presentation, followed by 2 minutes for Q&A. A gentle reminder will be given at the 9-minute mark. All participants are requested to remain connected until the closing remarks. For any queries or updates, please use the chat box. Now, before we begin, I would like to introduce the session chairs for this session. Our first session chair is Dr. Murad Aygir, who is an assistant professor in the Faculty of Architecture at Ankara University, Turkey. With over a decade of experience in academic research and project management, he specializes in digital transformation in the built environment. His research focuses on building information modeling, that is BIM, digital twins, automated code compliance, and knowledge representation, advancing intelligent and data-driven construction practices. Welcome, sir. Would you please like to share any welcoming remarks with us?
Hello.
Hello, sir.
Okay, I want to give about my some professional information. And hello, everyone. My name is Murat Aydın. I am currently working as an assistant professor at Ankara University, and I am also an architect. So today we have 10 papers. So each paper will have 10 minutes for presentation, 2 minutes for questions and answers. If you let us begin with our first speaker, if it's okay. Okay.
Yes, sir. Thank you, sir. This session is co-chaired by Dr. Vidula Meshram, who is an assistant professor in the Department of Computer Engineering at Vishwakarma Institute of Technology in Pune, India. She has 19 years of professional experience with expertise in assistive technologies, Internet of Things, machine learning, and computer vision, contributing actively to teaching, research, and academic innovation.
Thank you,
Welcome,
ma'am. Am I audible?
Yes, ma'am.
Yeah. So thank you so much for the wonderful introduction, and thank you for organizing such a ICTIS 2026. I congratulate all the participants who are going to present the paper, and all the best to all of them, and look forward to nice presentations. Thank you. We can start.
Thank you for the encouraging words, ma'am. Let's commence the session. First up, we have Felix Cowray presenting their paper titled An Integrated Machine Learning and Blockchain-Based Framework for Enhancing Fraud Detection in Digital Financial Services.
Are you able to hear me now?
Yes, you're audible.
Okay, let me share my presentation. How do I share? I'm not able to see the functionality of sharing. Where do I select the sharing of the presentation?
Screen share to show it to you, sir. Just wait a minute.
Yeah, I need to share my presentation. So
Um,
I'm not seeing the functionalities. Are you able to show me how to share the presentation here?
yes, I'll show it to you. Just give me a minute. Are you able to see my screen?
Yes, I'm able to see your screen, but
You'll
now,
be. Can you see this option right here? Share button.
okay.
If you are on a Windows PC, then you can use the keyboard shortcut Alt S, Alt plus S,
Alt S, Alt F.
Alt key plus S key.
Come again. Alt what?
So Alt key plus
Uh-huh.
S key.
All right. Right.
Sir, just send your presentation in the chat box. I'll share it. Till then, we'll proceed with the next presentation. Once that's done, I'll share your presentation and then you can present.
I lost that one. I'm not able to see when I click Alt S.
Just share your presentation in the chat box. I'll present it for you.
Oh, okay.
Right now, we'll be moving forward with the next presentation to save time. And once that's done, I'll share your presentation for you and then you can present it.
That's all right. That's fine.
Now we have Daksh Jetwa presenting their paper on Blockvote, a blockchain-backed IoT voting kiosk with biometric authentication and offline resilience for electoral integrity.
Hello, good afternoon. Am I audible?
Yes, you're audible.
Okay. Can I start my screen sharing?
Yes.
Okay. Good afternoon, everyone. Let me start with a simple question. Give me one second. Yeah. Am I visible too now?
Yes.
Yes.
Okay. Good afternoon, everyone. Let me start with a simple question. How many of us truly trust that our vote is counted exactly the way that we cast it? Now imagine a system where trust is no longer required because verification is built into the system itself. My name is Daksh Jetwa, and today I will be presenting BlockVote, a secure electronic voting kiosk. To understand the need for this system, let's look at this at a simple reality. Most voting systems today ask us to trust a black box. We press a button and we hope that the system does its job. But there are three major issues. First, centralization. A single authority is centralized, and if that authority malfunctions, that becomes a single point of failure. Second, lack of transparency means results cannot be independently verified. Third, weak identification verification allows risks like impersonation and duplicate voting. So the real question becomes, can we eliminate trust altogether? What if we could design a system where fraud is not just unlikely, it's mathematically impossible? That is the idea behind BlockVote. Blockvote combines blockchain, biometric authentication, and embedded hardware into a single unified system. So instead of relying on trust, it relies on cryptographic proof and verifiable processes. Let's walk through what actually happens when a person casts a vote. A voter walks up to the kiosk and places their finger on the sensor. The system verifies their identity, captures their vote, and securely processes it. The ESP32 microcontroller constructs a secure payload, which is then transmitted and recorded as a blockchain transaction. In essence, each vote becomes permanent, tamper-proof, and publicly verifiable. This is the block diagram which shows the entire journey of the vote from identity verification to encryption, transmission, and storage. Every step is secure. The key idea here is layered security. Even if one layer is attacked, the others can continue to protect the next system. Okay, so now let's experience the system from a voter's perspective. The voter scans their fingerprint, verified in under 1 second. They can select their candidate using a touchscreen interface. The vote is encrypted, digitally signed, and securely transmitted. Even if network fails, the vote is securely stored into the kiosk and is then pushed onto the blockchain when secure connection is established. Finally, the voter receives a transactional hash, a receipt that allows independent verification of the vote. But how reliable is our biometric authentication in practice? We tested our system across multiple users and scenarios. We achieved 100% enrollment rate success, 0% false acceptances, and only a 2% false rejection rate. This shows that the system is both accurate and dependable. Security is important, but can the system perform in real-world conditions? Our results show that each vote takes approximately 5.7 seconds. This allows around 10 votes per minute per kiosk. With a low consumption of only 1.1 watts, the system is also suitable for remote and long-duration deployments. Now let's take a look at what happens when someone tries to break the system. We tested 3 major attack scenarios. Double voting attempts were blocked at the smart contract level. Man-in-the-middle attacks were detected through cryptographic verification. And even during network failures, no votes were lost because they are securely stored on the kiosk and then pushed when connection is established. This shows that the system is resilient by design. So how does Blockvote compare to existing systems? Traditionally, systems rely heavily on trust and lack transparency. Blockvote, on the other hand, offers strong verification and strong identity verification, public auditability, and extremely low risk of tampering. In simple terms, it replaces trust with proof. So let me end with this thought. Democracy should not depend on trust alone. It should be backed by verification. Blockvote demonstrates that it's possible to build a secure, transparent, and practical voting system using modern technologies. With future improvements like multi-modal biometrics and real-world deployment, this system has the potential to redefine how we conduct elections, not by replacing existing systems overnight, but by evolving them towards a more trustworthy future. Thank you. That is my time.
Yes, thank you, Daksh. It's a nice idea, but I did not see the architecture diagram of your system. Have you presented it?
Yes, ma'am. We did. I did present the workflow diagram.
No, architecture of your system. It is not there in PPT.
I can show it to you. Just give me 1 second.
Yes, and how is it different from your existing systems? Like, what is your contribution in the same?
Just give me 1 second, ma'am. I'll show you the diagram first. I'm starting my screen share. Yes, ma'am. So this is the diagram. So we're using an ESP32 model to cast our votes onto the blockchain. This is an LCD panel which can be used to select the candidates which we want to vote. And this is diagram label number 2 represents the fingerprint scanner that we're using in this current scenario.
So what is your contribution here?
So, ma'am, currently the technology that every major election committing body is using is they use the EVM machines, a black box. So everyone is aware of the recent scandal that happened. Again, there is no way to actually verify if it's true or not, because that is what the democracy that we live in lacks right now. There is no transparency. You have to take someone, you have to take someone for their word that they have. There is no proof. So what this changes, if you come and vote into a block vote, you will receive a transactional hash, which is only and only visible to you. So now you can go onto the governing, suppose the governing body has a website where they display all the hashes that they have. So you can go and verify if whether your hash key is aligned to the vote that you casted. So it's completely transparent. I cannot have your hash key, you cannot have mine. So I do not know who you voted to. You do not know who I voted to, but you yourself can verify who your vote went to, who did you cast it to.
So how much accurate it is? What is the accuracy?
So, ma'am, candidate regency, we tested on multiple databases. That was 100%. False acceptance also was 0%. But duality of the acceptance was 2%, which is around 15% lower than the elections that we face today.
Thank you.
No worries, ma'am. Thank you. Any other questions?
Only I want to say thank you for your presentation. The
Thank you, sir.
integration of IoT and blockchain is voting systems in a promising approach to electrical integrity. Thank you.
Thank you, sir. Thank you so much. Any other questions, sir?
I think we can continue with the third presentation, or maybe we can turn the first presentation if Felix is ready.
Okay, sir. Thank you.
Thank you, Dash, for your presentation. Now we have Felix Capre presenting the paper titled An Integrated Machine Learning and Blockchain-Based Framework for Enhancing Fraud Detection in Digital Financial Services.
Thank you, ma'am, for this opportunity. Let me just share my screen. I don't know why I was not able to see it. The sharing is at the bottom. So when my colleague was presenting, I was able to see. Okay, let me just share the screen now. Are you able to see my screen?
Yes.
Yes.
Thank you so much for this opportunity to make this presentation. Now, my presentation is actually on integrated machine learning and blockchain framework for fraud detection in digital financial services. So basically, we'll be combining technologies to secure digital transactions.
Sorry to interrupt you, but can you please maximize your screen?
Sorry?
Can you please maximize the screen, put it into presentation mode? You can press F5 for that.
+5. I should do what?
Press F5 button, Felix. F5.
F5.
Or there is a button on the left top, share your screen. This is a PowerPoint or another
Yeah. Should I remove it or what?
No,
Okay, you can move like this, I think.
Is it okay now? Maybe let me share it in this way, in this format. Are you able to see it, the screen?
Yes, it's visible. It would be great if you can just zoom in, but
Maybe
if you can't, it's still fine.
maybe you can zoom, Felix. Right top, there is a scale. Maybe you can zoom your presentation. We can read it. Top right, there is a scale. Can you see it?
Okay, I can see the.
Can you move your mouse
Yes.
top right? So sorry, not top right. Right down. Sorry, right down. There is a scale there. Can you zoom it? Not this. There's a scale.
My apologies for the delay.
Right down 100 number. Can you see it? You can change it 150 maybe.
I'm
Also,
not
No,
able
no,
to
no,
see.
Also, you
I
can do
don't.
the slideshow from beginning.
no.
Okay, maybe let me just share with the coordinator so that she can do it. Then I'll be able to present it so that I don't waste a lot of your time. You can go to the next presenter. I'll share it on the chat. Then she'll be able to move the slides for me. Is that okay?
Yes, that's okay. Or if the session chairs are able to, still see, we can move ahead.
Yes, it is visible.
Okay, let me just share the slides. Yeah, kindly move to the next presenter.
Okay. Next, we have Jaya Kohli presenting the paper titled Bug Severity and Priority Prediction Using Semi-Supervised Expert-Guided Labeling. Jaya Kohli, are you here with us? JADN Jaya Kohli. Are you present with us here? Okay, we'll be moving forward with the next presentation. Atikur Rahman will be presenting the paper on data-driven insights into climate change risk assessment.
Thank you. Thank you. If I get permission, I can share my screen. Thank you.
Yes, please proceed.
Is it okay? Is it visible to you?
Yes, it's visible.
Thank you. Respected session chair, distinguished guest, respected moderator, and the faculty members. Today, I will discuss about the topic New Zealand case study. My paper ID is 659. And I will present a data-driven framework to understand how people perceived climate-related risk. And our study shows climate risk is not only about physical hazards, it's also about how people cope with the hazards, respond them, and support against them. So I'm going to discuss, or I would like to emphasize the central idea of our paper, mainly. Our study focuses on the human side of climate risk in particular. And what makes people perceive climate change. So actually, and how can such understanding the people help policymakers communicate better and plan more effectively? I'm going to discuss the next slide. Do you hear me?
Yes, audible.
I hear you.
Some technical problems I'm facing.
You can continue with the presentation.
I can't move to the next slide. Just few seconds.
Please try stopping the screen sharing and then sharing it again.
Okay. Is it visible right now? Is it okay? Okay. In this background motivation, we study matters actually. Climate change is already visible in New Zealand through several major indicators, and these include warming trends, shifting rainfall patterns, sea level rise, and more frequent extreme events. And another challenge in us is uncertainty, and future climate outcomes depends on changing emissions, evolving technologies, and economic conditions, international cooperations. And because of this, scenario-based and evidence-based analysis is essential. And our motivation in this paper, and it's used to examine not only environmental hazards, but also how people understand those hazards in a real national settings. And our evidence gap, if I discuss this slide, our previous studies have shown that climate risk perception changes across time, place, and demographic groups. Concern is influenced not only by science, but also trust, emotions, values, and social norms and media framing. And although international research is growing nowadays, New Zealand specific evidence remains limited. And more importantly, many studies do not jointly test measured environmental exposure and human or demographic drivers in a single framework. This is exactly where we study contributes, and we build a factor-based risk perception index, combine natural exposure indicators within human factors. And when we set the risk is equal to hazard, exposure, and vulnerability. If we discuss the research focus, why we study this and what are the objectives behind of our study, the aim of this study is to explain climate risk perception in New Zealand, usually a data-driven framework that integrates environmental as well as social drivers. First, we constructed a reliable composite risk perception index using exploratory factor analysis, and then we tested natural drivers. As usual, we test human factors in the same framework. Third, we compared the exploratory power of environmental and demographic or social models. And finally, we define the strongest predictors that may help improve climate communication and adaptation planning. Now we can discuss the objectives. Actually, we wanted to quantify climate change risk perception in New Zealand using a large national-wide survey dataset. And we then aim to build a composite factor-based perception index from multiple survey items rather than relying on the one question. And after that, we integrated natural exposures indicators such as rainfall variability, and we focus extreme rainfall, drought, flood risk, temperature anomalies, and coastal erosions with demographic and social drivers such as disaster, community engagement, and trust in science. And finally, we set these variables and measure these variables using correlation and multiple regression model. And as at last, stepwise modeling is applied, and then we could generate actionable insights of climate risk communication and policy design. And from the literature view, if we discuss, first, we don't judge climate risk only by the scientific information. Feelings, trust, communication, and prior experiments also matter. And second, public concern differs by locations, social contexts, and demographic background. Third, growing exposure to floods, droughts, coastal erosions increase in public attention, but concern may also require to rise because of media narratives or political discussion. Our work follows this broader direction in the context of New Zealand. And if we discuss the data and methods, and this slide summarizes our analytical framework. First, we begin with national-wide survey data containing perception-related items and demographic variables and exposure variables. And next, we move to exploratory factor analysis. And then we estimate regression models separately for national natural drivers. We had 8,157 nationally collected data. And using that data, we just focus national drivers, natural drivers for demographic or social drivers as well. And finally, we applied stepwise regression to produce or to search the strongest predictors. And model comparison, if I discuss, the main modeling idea can be expressed simply. Perceived climate risk is a function of natural hazard signals, lived experience, trust, and information pathways. And if we compare our model comparison, actually, we first compared three models. National drivers model produced R squared value 0.912 and adjusted R squared, which is used to sort the strong predictors, and this is 0.896. And for the demographic drive model performs slightly better with R squared equal to 0.932 and adjusted R squared 0.98. And finally, stepwise model is applied. And here we get R squared value 0.917 and adjusted R squared 0.98 with a mellow CP value of 7.918. And it indicates our model is potential overfitting and model is okay. And if I discuss exploratory factor analysis before fitting regression models, we need a dependent variable. And we use exploratory factor analysis to identify the strongest survey indicators of perceived climate change. And two items were retained from our slide: strong loading of a single factor. One item was climate change being a major risk to ecosystem and biodiversity. And the other was about the long-term harm of climate change to physical health. If we say the validation part, and we get Kaplan-Meier-Olkin's value is 0.896, 0.838 indicates strong sampling adequacy. And Bartlett's test is statistically significant because which supports the factor structure. and the communities ranges from 0.58 to 0.82. And cron batch alpha is 0.92, which indicates excellent internal consistency. So the conclusion here is that factor-based climate risk perception measure is statistically reliable and suitable for the later analysis. And if we discuss natural drivers, actually we collected 6 drivers and we found that higher rainfall variability, more frequent extreme rainfall, greater drought severity, and higher flood risk, stronger temperature anomalies, and coastal erosions, and all are associated with higher perceived climate risk. And we already discussed the R-square value and R-squared, adjusted R-squared, which are highly significant overall model. And in this figure, we discussed the correlation and significant pattern for natural hazards. From this figure reinforces the previous findings, and as well as environmental exposures is strongly associated with public concern. The physical reality of climate stress is reflected in how people think and people about risk, climate risk especially. And demographic part in this part, human and social context. We discussed this slide. Actually, these variables show strong positive relationship with perceived climate risk, and personal experience with climate related disaster stands out as the strongest predictor. And this model performs very well with R-square 0.932 and adjusted R-square 0.918. And this tells us life experience and social engagement strongly shape how climate hazards are interpreted by the public, and people don't know, simply observe hazards. And if we discuss the figures, actually this pattern is strong and meaningful. Actually, this confirms climate risk perception using the p-values and correlation coefficients. And if policymakers want to understand public concern, they must look beyond physical exposure and also consider the social and experimental background through which people interpret climate information. And finally, we apply stepwise regression, and in between two drivers, we sort temperature anomalies, extreme rainfall, drought severity, and river flood risks. These are the strong predictors for natural signals. And from the human side, we retain predictors, disaster experience.
This is just a gentle reminder that 1 minute is left for your presentation.
Okay, and finally, if we discuss our integrated part, we integrate in integrated part actually several predictors, especially we focus disaster experience and trust in information institutions and climate media exposure. Actually, we use a test to see the strong difference among the groups. Actually, so climate perception is not merely environmental, it's rational. We can discuss it social and interpretive at the same time. And model validation, its focus, model performance matrices is used actually to evaluate how well a model predicts outcomes. The error matrices are very low and the residuals are centered about 0. So we can say this is clear systematic structure, and the strengthens, it means the model captures meaningful structure in the data. And there is a positive result because it suggests strong predictive performance and no measure bias present. So without any prediction. So prediction error is really good. And if we discuss the model diagnostics, the border pattern is clear. Both hazard exposure and human dimensions matter. Perception is especially sensitive to experience, trust, and information pathways. As natural drivers are very difficult to control, so we can focus adapting planning, improving public awareness, and targeted communication can enhance understanding concern, becomes more effective when it combines environmental monitoring with social understanding and post and discussion and policy relatives. Our findings suggest that climate risk perception is not only driven by the knowledge alone, and it is shaped by exposure, lived experience, trust, and access to information. So practical value of the study lies in helping policymakers identify which drivers most strongly shape concern where the communication status can be improved. And in the conclusion part, actually, we say the broader contribution of this paper is that it connects environmental reality with social understanding. And in doing so, offers a more policy relevant way to think about climate risk perception. Thank you very much. Thanks once again to the conference organizers. And thank you very much for your kind attention. And I will now be happy to answer any questions from you. Thank you.
Thank you, Atik, for the presentation. I would like to know, which data set you have referred for this?
Actually, this study used data from National Wide Survey of 8,157 adults across different regions of New Zealand. And responses were collected using 5-point Likert scale, and only complete and internal consistent responses were retained after cleaning and validation.
Okay, so which features or say parameters you have considered while training?
Actually, we use lots of parameters. Actually, spatially, we apply stepwise regression, spatially, to detect strong predictors, and we remove the less important factors.
So, based on whatever study you have done, what are your recommendations?
Actually, recommendation, if I may, actually, this is the very brilliant question nowadays, because sea level is increasing according to the New Zealand International Atmospheric Department. So actually, we believe building a valid climate risk perception index using exploratory factor analysis, and people can get benefit from this paper using better risk communication. And spatially, we conduct this study using natural drivers as well as demographic drivers in the same single integrated framework, actually to quantify the joint effects of measured environmental exposures and human drivers to set model-to-model comparison, a policy-ready short list of the strongest predictors for target risk consumption. Communication and adaptation policy is very required.
Thank you.
Welcome.
Can I
Thank
ask
you.
a question?
Sure.
Thank you for
Yes.
presentation. Your data-driven approach provides valuable insights into climate change risk assessment. But are you considering validating the New Zealand findings in other cultural contexts, such as Asian countries?
Actually, this is the limitation of our paper, especially we select New Zealand because it's a strong case, because climate change effects are already visible there through warming, rainfall shifts, and drought and floods, coastal erosions. Also impacts vary by region, so it's a meaningful settings for studying how environmental exposure and public perception interact. Also, we can apply this study for different countries, for different places according to their demanding factors.
Okay, thank you.
Welcome.
Thank you, Abhikar, for your presentation. Next, we have Felix Kabe presenting.
Okay, you can share the presentation.
Yes.
Thank you very much. You can go to the next slide. Yeah, like I said when I was presenting, this presentation is actually looking at two different technologies that we can put together, machine learning and blockchain. When we integrate them to see how we could use this to solve the current or contribute to having solutions in the digital financial services. So the combination of the two technologies will help us to secure digital transactions. By the end of the presentation, you will agree with me that my paper is contributing to the secure, adaptive, practically deployable machine learning and blockchain fraud detection. So a framework that will help to enhance real-time detection, transparency, trust, and resilience in the digital financial services. You agree with me that we are having a big challenge in this space. You can go to the next slide. The background to this is that in the digital financial services, we have, transactions are fast. There's the convenience in digital financial services. And also we are adopting these in a lot of spaces like banking and in the MNOs. Yet we are having some challenges that are affecting these, even when there are benefits that are accruing to these transactions. We have fraud challenges. Fraudsters are trying to exploit the digital vulnerabilities through a lot of methods like phishing, SIM card swap, and social engineering attacks. So in the current situation, we do have limitations in the traditional approach of fraud detection. That is when we just use machine language alone, or perhaps the blockchain approach. So you've got static rules and manual reviews that struggle to detect evolving fraud, causing false positives and delayed transactions. So again, then we have the innovative and fraud detection approach that we are considering. I don't know, my screen keeps moving here. I don't know whether it's that side. Okay, you can go to the next screen. We are looking at the impact now in the financial services. What are we experiencing? So you see that there are a number of fraud types that are experienced on these digital financial platforms. You have phishing and social engineering. You find that sometimes you receive a message on your phone, whether it's SMS, whichever method they use. Sometimes fraudsters will contact you. They may even call you to tell you what they feel you should do. The interest they have is just to steal your assets of identification, passwords, and so on. We do have identity fraud and impersonation. They may steal maybe your access identifications into your digital spaces, and they will present themselves like they are the real persons. Sometimes they may even take over your entire account. I remember one time I lost my Facebook account because I was hijacked. We have serious tools today, such that if you are just looking at passwords, where you are just looking at what not combining with other options like maybe biometrics, it becomes very easy because the fraudsters use a lot of tools just to come up with identification so that they can easily access to your assets. There's SIM swap, where they would exchange your SIM card with theirs, and they present like they are actually the owners of the digital space. Sometimes it's payment manipulation. They'll trick users into authorizing fraudulent transfers. Then we also look at the card not present fraud, which is unauthorized online transaction using stolen cards. I remember one time I had three transactions hitting my account, and I'm in Lusaka, Zambia here. The person who was hitting me was in Johannesburg, you know, and I had to go and close the account. So I suffered that loss, but the bank had to refund me. There's also business email compromise. So as one type of fraud that is being experienced, there's malware and baiting attacks, which is malicious software capturing sensitive user data. You can go to the next screen, please. So we look at machine learning fraud detection. Next slide. In the machine learning, we have supervised learning and unsupervised learning. We've got different algorithms which do different functions, like there's logistic regression, which is supervised learning. It is interpretable and fast as one of its strengths. It is for digital financial services, you can use it for baseline risk scoring. There's random forest, which is supervised learning. It is robust and enables ensemble learning for use in digital financial services. It is quite central for fraud detection. There's gradient boosting, which is also another supervised learning algorithm, which is very high in accuracy with imbalanced data. It helps a lot in large-scale fraud detection. Another supervised learning is the neural networks. Its strength is learning keep on evolving. So when it sees patterns that are new, it keeps on adapting itself to new patterns, which the benefits for the digital, or how we use this in digital financial services, is that it can adapt to fraud learning. There's isolation forest. This one is unsupervised learning algorithm. It is the strength is that it is, you know, it can detect anomalies, you know. Then it can also be used in emerging fraud patterns. Then we have the K-means algorithm, which is also unsupervised. This one looks at the behavior of the fraudsters or the attacks. So it will be able to cluster the behavioral patterns and be able to indicate what it could be. So it's used in user profiling. You can move to the next slide. So what we looked at was machine learning. What about the blockchain?
Felix,
Blockchain.
I'm sorry to interrupt you. Just know that 1 minute is left for your presentation. So please speed it up.
Thank you. So for the blockchain, you see that blockchain is used for decentralized transaction records, for smart contract automation, and for decentralized identity verification. So it comes with its strength in that space, the way I put it. So go to the next slide. Next slide, please. Next slide. So when we integrate the two, the machine language and machine learning and the blockchain, we come up with a very strong tool that will be able to combine efforts to detect a number of things. In fact, in my thesis, this is what I'm looking at, and I've come up with a very good solution, which has been tested on the prototype, and it has given excellent results. So in this case, you've got the two technologies which put together, they come up with strong results. Let's move to the next slide so that we see what I'm talking about. The next slide. So when we combine, we come up with a framework that combines the two technologies. Of course, there will be some challenges and there will be some benefits. Let me start with the benefits. It brings real-time detection, the tamper-proof audits, And in this case, the screen, can you move your mouse? I think it's not able to see the bottom line of the table. Yeah. So there is also the user trust that comes with the blockchain. So basically, there is reliability of security for the digital financial ecosystems. We have the immutable fraud logs that whatever is done coming from the blockchain, the logs are kept and you're able to track. So from the machine learning, you are able to revisit these logs and also attend to the fraud. Challenges are not so much serious. There is delayed. Maybe there could be some delay on the machine learning detection. You could have maybe the high transaction fees and and also retaining costs on the use of the technology. Otherwise, basically, what we are saying is the two technologies coming together, they come up with a robust output. You can go to the next slide. Next slide, please. So this is the framework.
Felix, again, sorry to interrupt you, but you've exceeded the time limit, so please conclude your presentation.
Okay, let me just conclude. So this is just a framework that I was talking about. Let me go to the conclusion. The last slide. Next slide. So basically, the takeaway, no, before this one. Yeah, the takeaway from this presentation is that the integrated fraud detection framework combines machine learning and blockchain to overcome limitations of traditional fraud detection systems efficiency. There is also multi-level authentication that is involved when you combine the two technologies, which make the system become robust. For future research directions, we can look at the focus on explainable artificial intelligence, privacy-preserving machine learning, scalable blockchain, and interoperability with emerging technologies. So the real-world deployment and evaluation has that it emphasizes on the use, your mouse please, the use of the centric studies, performance evaluation for sustainable adoption in diverse financial environments. With this presentation, I'm free to open, or I'm open to any question that you may have. Thank you so much for this opportunity.
Thank you, Felix. Finally, you have done the presentation after 2-3 times attempting to do so. So
Thank you.
Thank you. So can you tell me the application areas of the system that you have designed?
Sorry?
Application areas, where can we use the system that you have designed?
Where this will be utilized in the central bank, I've actually included the central bank component, the central bank digital coin. And so when you have the MNOs, they can share this tool with the banks and the central bank to detect whenever. So it's an app that could be used by anyone who has a mobile phone. So it is something that could add a lot of value to the economies of the world and also to the institutions, financial institutions. Is there any other question?
Thank you for your presentation, Felix. We'll be moving on to the next presentation. And before we move on, this is a request to all the presenters. Please do not exceed the 10 minutes time limit for your presentations. Now we have Shreyas MS presenting the paper titled Design and Analysis of Photonic Crystal Nanocavities Based Force, Pressure, Biochemical, and Temperature Sensors using Cantilever Beam and Diaphragms on SOI platform.
Thank you.
Shreyas, you may please start your presentation.
Yeah, sure. Okay, thank you. Good afternoon, everyone. Respected chair and participants. I am Shreyas MS from Vishveshwaraya Technological University and I am research scholar. Today I will present my work on crystal nano cavity based multi-parameter sensors on SOI platform. I will briefly cover the problem statement, proposed designs, modeling, machine learning integrations, results, and applications. And in the next slide, introduction. Photonic crystals nanocavities provide very high sensitivity due to strong light-matter interactions and high Q factor. They enable detection of multiple parameters like force, pressure, and biochemical changes on the single chip. And in the problem statement, existing sensors mostly detect only one parameters. They suffer from fabrication errors and cross-sensitivity issues. Also, there is no unified platforms with intelligent calibrations, limited modularities, and missing calibrations. In the objectives, the main goal of this work is to develop a multi-parameter sensing with machine learning enhanced calibration with high sensitivity. And in the key contributions, this work proposes a novel nano-cavity designs integrated with mechanical structures, and it combines optical and mechanical modeling and introduces machine learning to improve the accuracy of the work. And in this, photonic crystals nano-cavity designs and coupled optical mechanical modeling and machine learning based calibration framework comprehensive characterizations. In the related work, we find the gap analysis. That is, previous work focuses on single parameter sensing. However, no work combines multi-parameter sensing with machine learning, which is the key contribution is here in this work. In the proposed system, the system uses a photonic crystal structure with integrated cantilever and diaphragms for sensing multiple parameters through resonance shift. In 2D photonic crystal lattices, mechanical transductions, optical resonance detection, and integrated modeling. In the device architecture, a triangular lattices photonic crystal is used with a defect cavity to confine light and achieve high sensitivity. In the 2D triangular lattices, air was attached is silicon device layer arranged in the periodic triangular lattices in the point defect nano cavity, created by removing or modifying selected holes to form a localized optical cavity for light confinement and resources. And in design parameters, lattices contain constant is 420 nanometers, hole radius is equal to 0.2 nanometers and optimized for 1550 nanometer operation is near infrared wavelength. In nano cavity designs, two types of cavities are used here, L3 and point defect, achieving Q factor above 15,000. In the next slide, mechanical integration, cantilever and diaphragms transducer for force and pressure. Cantilever is used for force sensing and diaphragms for pressure sensing, both integrated with the photonic structures. In the working principle, any physical or chemical changes shift wavelength, which is measured for refractive index changes, temperature variations. In the next slide, this shows the optical modeling using the FDTD simulation. FDTD means finite difference in time domain. Maxwell equations are solved to analyze light behavior in the nanocavity. The design achieves resonance around 1550 nanometer with IQ factor above 15,000. And then the spectral response shows as a sharp Laurentine peak indicating strong confinement. In the mechanical modeling, these slides explain how mechanical deformation is calculated. In this mechanical modeling using FEM simulation, FEM means finite element method. The cantilever bends under applied force and the deformers deflects under pressure. These deformations are calculated using classical mechanics equation. The mechanical changes are coupled with optical simulations. In this slide, this slide shows the fabrication process of the devices. It starts with SOI wafer preparations followed by E-beam lithography and etching. Wafer HF is used to release the mechanical structures. The process is compatible, enabling large scale and fabrication process. In the SEM characterization, this slide shows SEM images of the fabricated devices. It confirms uniform hole patterns and correct cavity formation. The mechanical structures are successfully released, and in this validates the fabrication quality. And in optical characterization setup, optical characterization tunable laser is used to input light into the device. The output spectrum is measured using an optical spectrum analyzer. Next, later Laurentine fitting is used to extract resonance wavelength and Q factor. And in the results and performance, presents the overall performance of the proposed sensors. The device achieves a IQ factors above 15,000, indicating strong light confinement. It supports multiple parameter sensing, including force, pressure, and refractive index. Machine learning further improves accuracy by around 30 to 35%. Later, sensitivity table. In this table shows sensitivity and performance for different sensing parameters. The devices achieves high sensitivity for force, pressure, refractive index, and temperature. It also provides good resolution and wide operating range. And this demonstrates the capability of a single platform for multi-parameter sensing. Next is noise and LOD analysis. Hello, ma'am.
You have 1 minute left for your presentation.
Sure. This slide shows noise and limit of detection analysis. Various noise sources such as laser noise and thermal drift are considering. And in this, detection limit is calculated using the 3 sigma methods. And the result shows very low detection limits, indicating high precision of the sensors. And And in the next comparisons, compared to existing work, this approach provides higher Q factor and support multi-parameter sensing. And later applications, label-free biosensing to industrial monitorizing, environmental monitoring. Future work. In the future work, experimental validation and on-chip integration. The future work includes integration with on-chip systems. Later, lastly, in conclusion, this work presents a unified multi-parameter sensing platform with high sensitivity and machine learning enhancement. By using novel photocrystal architecture, platform promises and superior performances, manufacturing scalability, machine learning enhancement, calibrations. Thank you. Any questions, please ask me.
Thank you. Can I ask a question?
Yeah, sure, sir.
Thank you for your presentation, Sharia. The innovative sensor design demonstrates how photonic structure can enhance measurement precision. And I want to ask, do you plan to apply this system in real healthcare environments?
Sir, in real work environment I worked on, I'm in the beginning stage of the research. By using the biosensors, I applied this all formulas, photonic crystals.
Okay, thank you.
Thank you for your presentation. Next, we have Muhammad Shahidul Islam presenting their paper on early structural break detection using volatility signature mining.
Hello. Do you hear me?
Yes, you're audible.
Okay, I'm sharing my slide. Can you see my slide?
Yes, it's visible.
Okay. Thank you so much, everyone, to attend this international conference. My research title is the early structural break detection using volatility signature mining. I am the presenter, Mohammad Shahidul Islam, Faculty of Science and Engineering, Bangladesh University of Business and Technology, Dhaka, Bangladesh. And my co-author is MD Rahan Habib, who is also from the same institution. So these are the agenda that I will present in my presentation. The first one is the introduction, the literature review, research gap, research objectives, methodology, analysis discussion, results, and finally the conclusion. So this is the introduction. So mainly I am using an Indian currency market for our analysis because actually foreign exchange markets are very complex, non-linear, and highly sensitive to economic and financial shocks. And exchange rates often exhibit sudden quantity bursts and structural breaks. You know that actually in traditional linear stationary model is struggle to capture this dynamics, especially for New Zealand exchange market. Signals for market stability. So this is one example you can see from the figure. This is the daily time series for the concept market for New Zealand exchange market, and this exchange rate from 1999 to 2017. And from this figure, we clearly exhibit that the clear fluctuation highlight periods of appreciation and depreciation, and several sharp declines and recoveries indicate structural breaks and volatility in the currency exchange market. And this pattern actually justifies the need for the advanced change point detection. And we have to identify the structural event, structural event point, and predictive modeling. So understanding this dynamics actually is very crucial for forecasting and early warning signal generation. So these are the literature review actually from where we get the idea about our research. So mainly actually we focus on the relevant literature, especially on the foreign exchange and market and financial time series. And also we focus on the methodological studies based on the research relevance, thematic categorization, change point detection and time frequency analysis, weblet-based methods, county link currencies, and some research actually focus on an integrated framework for structural break detection. So these are the main literature review we study for our research. So these are the research gaps that you find out from the literature review. So the first one is the limitation of linear and stationary models. So actually, from the most of the research, actually we see that they use linearity and stationarity method they used already, but they are actually failing to capture the complex and dynamic behavior of extended movements. So this is actually a research gap motivated us to further research. And the second one is the lack of early warning mechanism. The next one is the fragmented use of analytical techniques, then dependence on parametric assumptions, and finally insufficient focus on the business currency market and interpretability. So these are the mainly research gaps that we find from the literature review, and we are trying to sort out to solve our problem by using this research. So these are the objectives of the study. So the main objective is to detect the structural breaks and characterize volatility in the New Zealand by US dollar exchange rate. And the second one is develop a robust early warning framework for marketing staffing. So the first actually we focus main objective of this group. In future, actually, we have a big extend research. Alright. So yeah, so this is the methodology. So table one actually overview of experimental design and model configuration. So the first stage is the data collection. So we have FX data. We collect the data. Daily need the US dollar data actually collect from the reliable financial database, which is actually International Monetary Fund. The second stage actually we estimate the volatility, and for this region actually is the sliding window. And sliding window we use the size 5, window size 5, and compute the short-term volatility. And then we use the change point detection method, and fastly actually we use the high inequality to detect the abnormal volatility exceeding statistical threshold. And then segment based on the change point detection, we segment our total data set. And then we apply the wavelet transform to extract the feature from the data set. And then we identify the pattern, like event, stable, and post-event pattern we identify. And finally, actually, we perform some statistical test to validate our results, and especially use the non-parametric test because our data is non-normal. So use the Puskal-Wallis and the effect size method for regime difference. So these are the analysis and discussions. So mainly, actually, we use the following method to estimate the volatility. So we calculate this volatility by using the difference between the average currency value at the first window and the average currency value at the next window. And by calculating this volatility measure with the sliding window, which the size is 5. And after calculating this volatility, then we measure the halving bound, which is calculated from the halving inequality. And halving inequality, and actually we denoted by it 5, which is the halving bound. And we are saying that if the volatility exceeds this halving bound of 5, then actually we call a change point detect. But otherwise, we can say that there's no change point detected on the currency fluctuation. And by using this our change point detection method, we detect a total 2009 sequence, and actually we perform a restriction for the data because we need some validation for the statistical validation. So that's why actually at least 6 data points. So we have we start just recommend the 6 data points for the statistical validation. And in that way, actually, in total, we get a 2009 sequence for our analysis. Okay, so after segmentation of the data set in 2009 sequence, then we actually perform the wavelet analysis and extract the features. So figure 2 shows the original signal and the wavelet coefficient scaleogram for the Nielsen currency market. So from the figure, actually clearly see that the red region corresponds to areas of high coefficient values, while the blue region indicates the low coefficient magnitude. So from the figure, actually the red region indicates the high coefficient value, and the compared to the blue region indicates the low coefficient value. And in the second figure, figure 3, it's indicate the red and blue regions actually synchronized with raw frequency data, and a threshold are applied to segment 3 distinct regions: 2 red region and 1 is the intervening blue region. Because actually we are selecting the 2 red region. This is the main reason is the first red region is the reaction just after the currency fluctuation. Okay, and the last red region and the second red region, this is the just before the currency fluctuation. Okay, so that's why actually we chose the red region, and the middle one is the winning region, because of this is the stable situation. I mean, this will be no reason for the currency fluctuation. Okay, so we select the red, the region 1, 2, 3, and then we will perform actually our analysis by using these 3 regions. Okay, so these are the results. So when we perform the non-parametric test, Pascal, Wallace, and over. Yeah.
Sorry to interrupt. Just a gentle reminder that 1 minute is left for your presentation.
Okay. Yes. So these are the results actually. So from the results, this is the Pascal, Wallace, and over test. So from these results, you can see that the p-value is very poor. I mean, it is significant or result significant. So it indicates that actually the large effect size confirming also the large effect size omega square, which indicates that large effect size, and our test is significant. So it indicates that actually our math is working properly, and region 1 represents positive volatility, region 1, and region 2 reflects stabilization, and region 3 indicates the variable volatility, escalation, and price market uncertainty. And table 3 also represents the descriptive stats, and from this descriptive stats, we also see that region 3 has a high impact for the currency fluctuation. So these are also results from the box plot and the Berlin plot, and now this is the heat map visualization. So from all the figures, you can clearly see that region 3 is different, completely different from the other region, region 1 and region 2. So which indicates that region 3 has a high impact for the currency fluctuation, and it indicates it gives us an indication that something is going to happen in the near future. So yeah, conclusion. So this study proposed a non-parametric framework combining exchange point detection and web-based analysis to identify structural breaks in the Indian currency market. And our result shows that we are getting a region. I mean, we can give a warning signal before the currency fluctuation that is something is going to happen in the near future. And actually, one limitation is that at this moment, actually, we are using only the Indian currency market, but in future, actually, we have a plan to generate our idea to other currency market as well. Yeah, so thank you so much. If you have any questions, then please ask me.
Hello. Yes, sir. So, sir, having said the limitation, when does your system fail, and how do you address it?
Sorry, I don't get it.
So you have already conveyed your limitations. So in which scenarios does your system, this method fails, and how do you address it?
Actually, I'm saying that at this moment, actually, I'm considering only for the retail currency market. Okay, and one thing is that I'm not using the other currency market at this moment. So when actually we consider our data set, then first of all, we consider at least we have 60 data points for the statistical validation. So sometimes actually in our analysis, we get some sequence which has, very few data set. After some data, like 25 or 30 data points, then actually it fluctuates. But actually we cannot say that this fluctuation is the reason for the near currency fluctuation. Okay, so we actually remove this sequence from our analysis. Okay, so we only predict the data set which have at least 60 data points, and then for those sequence actually will at this moment we can predict for the currency fluctuation near future.
Any other question?
No, not from my side.
Thank you, Shaidul, for your presentation.
Okay, yeah. Thank you so much.
Now we have Diego Perez Lopez presenting the paper titled Genetic Programming Applied to Matrix Factorization.
Hello, can you hear me?
Yes, you're audible.
I'm gonna share my screen. 1 second. Can you see the slide?
Yes.
Okay. One second, because I have a problem with the presentation. Okay, now. Hello everyone, my name is Diego Perez, and I'm very happy to be here today to present our research, Genetic Programming Applied to Matrix Factorization. Here is the agenda of this presentation. First, I will introduce the problem and the context of recommender systems. Then I will briefly explain matrix factorization and its main limitations. After that, I will present evolutionary approaches, focusing on the EMF model. Next, I will introduce our proposed model GPMF. Then I will show the experimental results, and finally, I will present the conclusions. Recommender systems are widely used in many real-world applications, such as e-commerce platform, streaming services, and social media. These systems are very important because they help users discover new content that matches their preferences. At the same time, they help companies to increase user engagement and improve customer satisfaction. One of the most popular techniques used in recommender systems is matrix factorization, which models the interaction between users and items. However, despite its popularity and effectiveness, matrix factorization still has some important limitations, especially in terms of flexibility and prediction accuracy. The main idea is to represent the data as a user item matrix, where each value corresponds to a rating given by a user to an item. However, in real scenarios, this matrix is usually very sparse because users do not rate all items. To solve this problem, matrix factorization decomposes this matrix into two smaller matrices, one representing users and another representing items. These matrices contain latent factors, which capture hidden characteristics of users and items. By combining these latent factors, the model can predict the missing ratings. Some popular models based on this approach include PMF, biased MF, NMF, and BNMF. Although matrix factorization is very effective, it also has several important limitations. First, these models usually have a fixed structure, which means that they cannot easily adapt to different types of data or user behavior. In addition, their performance strongly depends on the selection of hyperparameters, such as the learning rate or the number of latent factors. This makes the optimization process difficult and often requires manual tuning. Another important limitation is that these models have limited flexibility when trying to capture complex interactions between users and items. Because of these limitations, there is a need for more adaptive and flexible approaches that can improve prediction accuracy. To address the limitations of traditional methods, evolutionary approaches have been proposed. One of the most important techniques in this area is genetic programming, or GP. Unlike traditional optimization methods, GP does not try to directly find the best parameters. Instead, it evolves solutions over time using an evolutionary process. In this context, the model Evolutionary Matrix Factorization, EMF, was proposed. This model applies genetic programming to matrix factorization. In EMF, its solution is represented as a tree, where mathematical expressions define the interaction between users and items. These trees evolve through different operations, such as selection, crossover, and mutation. However, although EMF introduces a more flexible approach, its results do not outperform traditional matrix factorization models. To overcome the limitations of EMF, we proposed a new model called Genetic Programming Matrix Factorization, or GPMF. The main idea of this model is to increase the flexibility of the learning process by evolving not only the model structure, but also its hyperparameters. In the EMF model, genetic programming is only used to evolve the mathematical expressions that define the interaction between users and items. However, in our approach, we extend this idea, but also evolving key hyperparameters, such as the learning rate, regularization, and number of iterations. This allows the model to jointly optimize both the structure and the training configuration. As a result, GPMF can explore a much larger solution space and potentially achieve better prediction accuracy. Now I will briefly explain how the GPMF model works. In this approach, each individual is not just a simple mathematical expression, but a complete program. These programs can include different elements such as mathematical operations, conditional statements like if, else, and different types of operators. These components allow the model to represent user-item interaction in a much more flexible way. Compared to EMF, where individuals are only trees with mathematical expressions, GPMF introduces a more complex structure that can adapt better to the data. This increased flexibility is one of the key factors behind the improved performance of the model. Now I will explain the evolutionary process used in the GPMF model. First, we generate an initial population of random individuals, where each individual represents a possible solution. Then each individual is evaluated using an error metric, in our case, the mean squared error. After that, we select the best individuals based on their performance. These selected individuals are used to generate new solutions through crossover and mutation operations. Crossover combines parts of two individuals, while mutation introduces random changes. This process is repeated for multiple generations, allowing the population to gradually improve over time. Now I will describe the experimental setup used to evaluate our model. We use the movie lens dataset, which is a widely used benchmark in recommender system research. To evaluate the performance of the model, we use two standard metrics, mean absolute error and mean squared error. These metrics measure the difference between the predicted ratings and the real user ratings. We compare our proposed model, GPMF, with several baseline models, including PMF, biased MF, NMF, BNMF, and also the EMF model. This allows us to analyze how our approach performs with respect to both traditional and evolutionary methods. Now I will present the results obtained by our model. In this table, we compare GPMF with several baseline models. As we can see, GPMF improves the performance of EMF in both evaluation metrics, achieving lower MAE and MSE values. In addition, GPMF also outperforms the PMF model, which shows that this evolutionary approach can improve prediction accuracy. However, biased MF still achieves the best overall results. This means that although our model improves previous evolutionary approaches, there is still room for improvement compared to the best traditional methods. In conclusion, we have proposed a new model called GPMF, which applies genetic programming to matrix factorization. Our results show that GPMF improved the performance of the EMF model, demonstrating the benefits of evolving both the model structure and its hyperparameters. These findings suggest that genetic programming is a promising approach for improving recommender systems. However, our model still does not outperform all traditional methods, which means that further improvements are needed. Overall, this work provides a step forward in the application of evolutionary techniques to recommendation systems. Thank you very much for your attention. Any questions?
Yes, thank you for the presentation. So can I ask a question?
Yes.
So if your matrix is a sparse matrix, how will your method perform?
Sorry, could you repeat?
If the input matrix is a sparse matrix, I guess you know what is a sparse matrix.
Like density or dispersion? This type of metrics.
Okay, so how will it perform in case of sparse matrix?
In this case, the movie lens dataset is 100K ratings, and the density is like 4%. That means that a very few users bought the items. So in the future, we can use metrics like density or sparsity to see the difference sparse of the data sets using in this approach.
Okay.
Are there any other questions?
No, ma'am.
Thank you for the presentation. Our next presenter is Jyotika Bora, presenting the paper titled Graph Signal Processing for Multi-Channel EEG Signals Integrating Structural and Functional Connectivity.
So let me share my screen. Can you see my slides?
Yes.
Okay. Good afternoon, everyone. Thank you for the opportunity to present our work, graph signal processing for multi-channel EEG signals integrating structural and functional connectivity. So the motivation and contribution of our work, as we all know that the brain is a highly complex organ consisting of billions of neurons with extensive connections and interconnections. These neurons continuously fire and co-fire in coordinated patterns, giving rise to different brain states. When there is a disruption, dysregulation, or abnormal synchronization in these neural activities, it can manifest as various neurological conditions. Such changes may arise due to multiple factors, including chemical or genetic influences. So this motivates the need to identify reliable biomarkers that can help in understanding these conditions and potentially support applications such as brain-computer interfaces. So in this work, we focus on analyzing EEG signals using graph-based methods, particularly graph signal processing and graph convolution neural networks. We used graph signal processing as it provides a framework to model brain activity as signal defined over connectivity graphs, allowing us to incorporate relationships between different brain regions. Here, our objective is to explore how multi-channel EEG signal can be modeled in a way that better reflect underlying neural interaction across regions. The limitation of conventional approaches is that it often treats EEG channels independently, which may overlook important interchannel relationships essential for understanding the brain connectivity. And to address this, we construct EEG as a graph by combining functional connectivity estimated using spectral coherence with domain-informed priors such as hemispheric symmetry, regional proximity, and spectral continuity across bipolar channel pairs. The contribution of our work involves a graph representation with graph signal processing method combining spectral connectivity domain-informed priors such as anatomical structures and regional proximity, a graph convolution neural network constructed to leverage this multi-channel EEG signal representation as graphs to learn discriminative embeddings. So the proposed framework, we take multi-channel EEG signal and pre-processing is performed, including independent component analysis, where it is applied to EEG signal to attenuate non-physiological and physiological artifacts such as muscle and ocular activities while maintaining the neural sources of interaction before feature extraction. Then we perform the windowing with 5-second non-overlapping windows. Then we define the graph constructions with node as bipolar channel pairs and edges as the hybrid adjacency coherence. And then those graph constructed is given as an input to GCNN as hierarchical node embeddings and plus graph global average pooling to learn discriminative features and then classification. And this is the framework block diagram of the proposed method using the GSP for multi-channel EEG signal. So the domain-informed priors involve the spectral continuity, where spectral continuity involves similar bipolar pairs share band coherence patterns. Hemispheric symmetry involves symmetry in inter or cross hemispheres as channels between FP1 and F3, FP2 to F4, F7, T3 to F8, T4. And the regional proximity involves region-wise activities happening, interconnections, that is frontoparietal, frontotemporal, anatomical neighborhoods. Now the functional connectivity. The functional connectivity, the node is captured by the edge weight. This representation further enables our graph convolution neural network to capture dependent dynamics. Each node corresponds to a bipolar channel pair and is associated with spectral connectivity values. In this representation, node corresponds to bipolar channel pairs and the edge weight captures connectivity between them. This allows the graph convolution neural network to learn patterns that reflect both local and global neural dynamics. So we performed our framework for downstream classification tasks and evaluated it over several baseline methods across 3 EEG datasets. That is 3 independent EEG datasets involving MDD, that is major depressive disorder, having 30 subjects of MDD versus 34 subjects of HALD. healthy controls. And then data set 2 is from Arizona, North America. This is also an MDD dataset, major depressive disorder, involving like 46 subjects of MDD and 75 subjects of healthy controls, and epilepsy datasets from Neurological Research Center in Bangalore, India. This is on 40 subjects involving samples of epilepsy patients, and then healthy controls of 20 subjects. So we compared our method across the baselines with fully connected network, random forest, convolution neural network, and a baseline for graph is graph convolution neural network and spectral GCNN. And ours, we propose graph convolution neural network shallow, where it contains 3 convolution layers without any hidden fully connected layers, and GCNN deep with 5 graph convolution layers, followed by global pooling and 2 hidden fully connected layers. These are the hyperparameters of our work. So the evaluation matrix we use as AUC and F1 score. Here are the results where the graph-based methods outperform the non-graph-based methods with 90 hours. Proposed method, the GCNN DEEP, has outperformed with 93% AUC on MDD dataset. And these are our key findings. Graph-based representation demonstrating improved performance over non-graph baselines, demonstrating its effectiveness. The GCNN DEEP achieves highest AUC across 3 datasets. The improvements obtained for explicit brain connectivity modeling, not just model complexity. This hybrid adjacency at anatomy plus coherence provides physiologically meaningful graph. Framework generalizes across different neurological disorders and acquisition conditions. The limitations of our work contains, as the datasets belong to different geographical regions, and this involves different performance gap in our model performance. With heterogeneous recording system across datasets, acquisition variability may confound the result. Subject level difference in anatomy, electrode placement, and condition severity may limit the generalization. The future work incorporates the graph attention mechanism to improve model robustness and handle subject-specific variability, explore the connectivity patterns and strength of node, and explore the reason and band of importance involving these particular neurological conditions. So in conclusion, we have proposed a hybrid graph signal processing framework combining coherence-based functional connectivity with anatomical domain priors for EEG graph construction. Framework validated across MDD and epilepsy datasets from 3 independent populations. GCNN DEEP achieved 93% AUC on dataset 1 and achieved high scores among the 3 datasets. Because of the nature of the data, difference in anatomy, electrode placement, severity of conditions, and neurophysiological patterns can confound the results, with subjects limiting generalization. For future work, as I have already said, we plan to incorporate in the study subject-specific variability test using leave one subject Lozo validation method and attention to the graph to improve model generalization. These are few of the references. Acknowledgement is this work is supported by Indian Council of Medical Research, ICMR. Thank you. I would like to take questions.
So thank you for the presentation. What are the applications of your system?
Yes, ma'am.
What are the applications of the proposed system, or where
Yeah, we can since this is an application for neurological condition biomarker detection. So using this method, we can find out the biomarkers that will help in understanding the neurophysiological conditions and potentially also support in brain-computer interface applications as well.
Yes, is it for any specific diseases or say emotion disease? emotion or stress level detection? Or
Yeah, for at this particular time, we are like doing a project with ICMR on mental health. So particularly this frameworks were mainly focused on mental health such as depression and anxiety. But later on, we are focusing to extend this work to neurological disorders to see and validate if this works in other conditions as well.
so, will the same data set suffice whatever you're going to do in the future?
It may not perform exactly the same. It has confounding issues, but yeah, we can like see if we can model these things using domain adaptation technique or whatever is possible in in the process.
Can I ask a question?
Yes, sure.
Thank you for your presentation, Judica.
Yeah,
In your work, you employ a hybrid model or hybrid approach. And what are the key advantages of your hybrid model compared to other data-driven methods in your presentation, in your study?
okay, so you're talking about the advantages over the other conventional methods, data-driven methods.
Yes.
Yeah, okay. So we have in this method, we have incorporated our graph-based method, both from the aspect of finding the interconnections between the channels and the bands. We have a functional connectivity and the structural connectivity in our model so that we can gain the interconnections happening between the regions as well as the frequency, the rhythms in between those regions represented by the channels.
Okay, thank you.
Yeah, thank you.
Thank you, Judika, for your presentation.
Yeah, thank you.
Up next, we have Samiksha Chowgule presenting the paper titled Multilingual AI Assistant with Edge Device.
Hello, am I audible?
Yes, you're audible.
Can I share my screen?
Yeah, please go ahead.
Yeah. So, good afternoon, everyone present here. Today, I, Samiksha Chowgule, along with my teammates Kirti Satpute, Krishnaraj Patil, Om Kumbar Dare, and Sumedha Patil from Marathwada Mitra Mandar's College of Engineering, Pune, India, will present our paper. So, as we all know, even today, millions in rural areas struggle to access timely and understandable healthcare. Rural communities face major healthcare challenges due to language barriers, low health literacy, and poor internet connectivity, making it difficult to understand medical reports and access proper guidance. To address this, we have developed a multilingual AI health assistant on low cost edge devices. This solution improves healthcare accessibility, ensures privacy, and empowers rural users to better understand and manage their health. These are some newspaper clippings highlighting the current healthcare situation in rural India. There is nearly an 80% shortage of specialist doctors in community health centers, which weakens primary healthcare delivery. Reports also show that about 60% of rural health sub-centers cannot handle basic conditions such as hypertension and diabetes due to lack of medicines. Additionally, rural areas have only 3 doctors per 10,000 people compared to 13 in the urban areas. Seeing these problems, we have defined our objectives. First, to provide multilingual voice and text based medical assistance, to analyze symptoms in local languages, to enable paramedics to assist uneducated patients, to suggest nearby doctors, and to ensure offline support with cloud sync. Now I'll briefly explain the two main papers that have inspired our work. The first paper is a multi-agent medical assistant for edge devices. It uses multiple AI agents trained on a large dataset to support features like appointment booking, SOS alerts, and basic health monitoring. The second paper, MedAid, uses large language models on edge devices to provide medical assistance with good accuracy and real-time responses. Now, in total, we have studied around eight research papers, and from all of them, we have identified some common research gaps and limitations. Most existing systems heavily rely on continuous internet, making them less effective in rural and low network areas. They also have limited multilingual support. There is poor inclusivity for low literacy users due to lack of strong voice-based or guided interactions. Rural challenges, delayed diagnosis are also not very well addressed. Many systems are fragmented, focusing on single tasks instead of a unified solution. Privacy and offline support are limited, and medical reports are not simplified into easy or local languages. This is the system architecture. I'll be talking about the system architecture and the methodologies which we have used. So starting with the user interaction layer, the users can interact through a web application using text, voice, or image input. The system is designed for both general users and paramedic assisted usage. Secondly, the language processing layer, in that we use LangDet for language detection, Google Translate API for translation, OpenAI Whisper for speech to text, and GTTS for text to speech. Our third module, that is the intent recognition and query classification, in which we have used sentence spot and cosine similarity for understanding the user intent and matching the symptoms. Based on this, the queries are classified into general health queries, symptom checking, and doctor recommendation. We have also used the MedText dataset from Hugging Face for symptom to diagnosis mapping. Thirdly, the response generation layer. It generates responses in the user's preferred languages and provides both text and voice output using the GTTS library, ensuring accessibility for low literacy users. The USP of our system, that is the report and prescription processing module, which will be implemented using OCR-based extraction for medical reports and prescriptions. This will help in converting medical text into simplified and understandable languages. And lastly, the feedback and learning module will add a feedback system to collect user responses and improve system accuracy over time through continuous learning and refinement. Our main target users include rural and semi-urban patients, paramedics and frontline health workers, government-run clinics and community health centers, NGOs and healthcare non-profits, and our secondary consumers can also be hospitals. Our future scope mainly includes integration with wearable devices for real-time monitoring of vitals such as heart rate, oxygen, and blood pressure, AI-based health risk prediction for early detection of diseases, expansion to more regional languages and dialects, advanced OCR for handwritten prescriptions and lab reports, visual AI diagnostics for detecting visible symptoms such as rashes or swelling, and scalable deployment through government schemes, NGOs, and mobile health units. To conclude, I would like to say that the main focus of our system is on inclusivity, privacy, and low-cost deployment, which makes it particularly valuable for rural and underserved communities, highlighting the potential of intellectual and human-centered technology to enhance healthcare understanding and empowerment. These are some of the references that we have used. This concludes our presentations. We are open for any questions.
Okay. Thank you, Samiksha, for the presentation. So have you developed a mobile app for this, or it is a web-based system?
Currently, ma'am, it is a web-based system.
Okay. So you are saying that the application is in rural areas. So what about the network connectivity?
Yes, so ma'am, we are going to make it completely offline. As I said even earlier, it will only use cloud syncing only when, for example, the one device, it can get internet once in a month or maybe twice a month, whenever possible. Only the feedback and the new data updation which is there, that will need internet. The other functionalities will work completely offline.
Can I ask a question?
Yeah, yes, sir.
It's a very interesting topic. Thank you for your presentation.
Thank you, sir.
And the multi-language AI assistants show how edge devices can expand healthcare accessibility. I wonder something that when enabling offline functionality on edge devices, how do you maintain both accuracy and speed of the model of your model?
So, sir, currently we have studied about two edge devices, that is Raspberry Pi and ESP32. And in that, sir, the data will be already pre-processed and stored. And we won't be using any cloud synchronization or internet when the system is working in the rural areas. Hence, the accuracy will be maintained as the new data, whenever we add the new data when it gets internet, at that time, again, we can test the system and make the updations that are necessary.
Okay, thank you. Thank you.
Thank you.
Thank you, Samiksha, for your presentation.
Thank you.
Now we have Noor presenting the paper titled ZKP Guard, a lightweight framework for verifying digital image authenticity and ownership.
Am I audible?
Yes, you're audible.
Is my slide visible to you?
Yes.
Good afternoon, everyone. My name is Noor, and I am a pre-final undergrad from LNM Institute of Information Technology. Today, I will be presenting our work, that is ZKP Guard. It's a lightweight framework for verifying digital image authenticity and ownership. The crisis of digital trust. Can you trust an image online today? Probably not. Systems we are currently used to verify images are broken in two ways. First one is the accept metadata. The metadata is the little information that is embedded inside the images. It can easily be changed. Second thing is you need to prove if you need to prove you are owner of the particular image, you need to share that image. So it questions your privacy. So we have a trust crisis, and that's exactly we are set to solve. Current state of the art work. People have tried to solve this problem before, like the photoproof research paper. They are using zero knowledge proof technology and they are verifying image transformations mathematically. They are using polynomial equations and deep mathematics. And there is one more example, C2PH standards that Adobe and Microsoft are using these days, but it is also based on metadata. So they use metadata for content provenance, but again, it can be easily forged. So these are cryptographically strong, but they come at a serious cost. The bottlenecks in existing systems. Standard digital signatures compromise privacy because you need original image file to verify anything. Like as you can see here, the photoproof research paper has produced massive impressive results. It takes 5 minutes for the whole process to generate the proof, and it uses a lot of memory. Like it uses around 2.6 gigabytes of memory, but our system has a very low latency, and we are able to generate the proof in 0.05 to 3 seconds. And it is all because of the ownership and verification part. We are not implementing the costly transformations. We are not focusing on the polynomial equations. That is why our system is lightweight. Yeah, the problem that we are solving is different, but yes, it is very efficient. The dual-log architecture. As you can see on the screen, we have implemented two layers of security. First one is the authenticity, and second one is privacy. For the authenticity part, we have used the ECDSA algorithm, which is elliptical curve digital signature algorithm. It seals the image, and like if someone tries to break the image or change it with any attack or do any tampering, the hash of the whole image will be changed, and we will be able to detect that this is not the original authentic image. The second layer of security is privacy, and we are using Schnorr's zero knowledge proof algorithms for them. And one more thing, we are using the discrete logarithm problem. So it is very next to impossible to reverse engineers that code that we will be producing for the privacy part, for proving the privacy part. So the system is very secure. So let me briefly explain you the mathematics behind it. First of all, we will break the image into bits, and those bits will be converted to a hash value using the SHA-256 algorithm. And then we will be using the private key of the camera to sign that particular hash into the image. So you cannot extract that particular hash from the image until and unless you have the private camera key. We are assuming that the camera are very secure. This is our assumption that the camera is very secure. Hence, it will be able to sign and protect that particular hash. The second is Schnorr ZKP generation, which will be used for the ownership proving part. So we will be making a commitment. G and H, as you can see here, are the points on the elliptical curve. E will be the challenge that will be sent to the verifier, which is asking honor the question, are you the real owner of this image? How we will prove that? We will prove that with help of this equation. As you can see on your screen, the equation marked in red, this will prove that we are the real owner of that particular image. And we do not need to show the actual image and metadata or anything else behind that image, and we can prove it using our method itself. So as you can see here as well, this is a dual lock architecture. Origin lock 1 is for the origin, lock 2 is for the ownership, and we are using ECDSA signature here. So here is the pseudocode for the dual lock verification. Like for those who are interested in the pseudocode implementation, this is a full protocol. It condensed into a short pseudocode. So let us move to the next slide. So our attack detection accuracy is 100%. We used the dataset USC SIPI dataset, and we tested on high resolution images, 500 high resolution images, and these are the different attack types that we applied to the image for getting the final results. Actually, in generally, 100% accuracy is a little bit suspicious. It is very uncommon to see that, but in cryptographic systems, it is generally assumed that the system is 100% secure from each and every attack. Only then we can say that a particular system is secure in terms of cryptographically. The machine learning models and statistical systems cannot be 100% accurate because it questions them, because it can be due to overfitting. But in case of cryptography, we do not have those things, and 100% accuracy is achievable. We will be using DIV 2K dataset in our next, it's our next evaluation target. So it will give us more idea about the system security. Benchmark visualizations. As you can see on the right side, it's a Lena image, and we are able to trace the portions in the image that were attacked by the JPEG compressions. As you can see this heat map here, the attacked regions are clearly visible in the image, and it can be proven that the image was attacked. And one more thing, if it will be attacked, even a single bit of the image changes, the entire hash will be changes. It will be detected by ECDSA signature, and we will be know that the image is not authentic. There are some changes made to it. So these are the performance and latency comparison. As you can see, we are able to generate the proof in 0.05 seconds, and the total latency is 0.13 seconds. Photoproof was using mathematical equations, polynomial equations. They are able to trace the entire history of edits made to a particular image. But our main goal is not that. We are focusing just to prove that is the image real, authentic, and is the person who is claiming to be the owner of the image the real owner or not? That is why our approach is slightly different from the photo proof ones, and our method is around 6,000 times faster than the photo proof. You can see the results here. Proof and key size efficiency. The proof that we use that we use to prove that a particular person is the real owner or not, that proof size is approximately 0.35 kb, which was 2.6 GB in case of the photo proof research paper. So that's a huge milestone for us. And whether you are using a HD image or using a 4K image, the proof size will remain the same, because the proof are ultimately made by the hash values that the particular image bits were converted to. So it will be remaining the same. And it's incredibly efficient. Coming to the conclusion and future scope, like we are able to implement a robust tamper resistance, and the future scope is public ledger integration. Like we have not yet tested it on live systems, whether our algorithm will work there or not. We need to implement a live testnet for that and estimate the real world gas cost, what will be the efficiency, what will be the is our algorithm really secure on that level? We need to work on that part. And we are also focusing on the image restoration part using neural networks. We need to make sure that hallucinations are not there. In order to do so, we can again use the same concept of ECDSA. We can integrate that ECDSA algorithm and make sure that each pixel of the image is original and authentic, and there are no hallucinations made by the AI for the image restoration part. We will be using deep neural networks for that in future, and this is our future work. This will be our future work. These are some of the references, some of the papers that we read, and like there are some limitations in some of these papers, some like computational overhead in case of photoproof research paper, and various other limitations in other research papers. We tried to solve some of the problems, but yes, there are some limitation in our paper as well. We acknowledge that, and we will be working on that part. For now, we are not able to recover the image. That is our main goal, image recovery through neural networks. It will be our future work. So that was all from my side. I would like to thank my mentor, Dr. Soumya Mukherjee, for providing me guidance and support throughout this project. I would sincerely thank to my college, LNMIT, for providing me opportunity to present this research paper. So thank you for the committee. Thank you for the ICTIS organizing committee as well for this conference. And this is my LinkedIn profile. You can connect with me on LinkedIn. And this is my email if you have any queries. Now I'm open to questions. Please ask your questions.
I only want to say thank you for your presentation, Noor, because
Thank
it's
you,
a
sir.
very good topic, and your lightweight framework demonstrates practical solutions for digital image authentically verification. So thank you.
Thank you, sir. Any questions?
No, no questions. Thank you for it. Was really nice presentation. Thank you.
Thank you very much, ma'am.
Thank you, Noor, for your presentation.
Thank you.
Last, we have Jaya Cody presenting their paper titled Bug Severity and Priority Prediction Using Semi-Supervised Expert Guided Labeling.
Okay. Good evening, everyone. My name is Jaikari, and I am presenting on behalf of our team from I211 Solutions. Today, I will sharing our work on automating bug severity and priority prediction using a semi-supervised expert-guided approach. Let me start by giving you the context for why this problem matters. Every large-scale software system generates a constant stream by bug reports. The challenges isn't just fixing bugs, it's designing which ones to fix first and how serious they really are. That process is called bug triaging. Manually doing this is very expensive, it is slow, and it is inconsistent. And as teams scale, the coordination overhead becomes enormous. One misclassified bug, treating something critical as minor, can mean hours of downtime or significant operational cost. And now the machine learning community has tried to address this. Classical models and even deep learning approaches have been applied, but they all share a common weakness. They need fully labeled datasets. And in a real industrial environment, building and maintaining those labeled datasets is simply not sustainable. Clustering-based methods offer some relief, but assigning labels at the cluster level without expert validation can propagate errors throughout their training data. So these challenges point to some very specific gaps in the existing research. Problem statement and research gap. We identified three core problems. First, the annotation bottleneck. Manually labeling thousands of bug reports in a dynamic industrial setting just doesn't scale. Second, public datasets simply don't have the feature that matter in a real enterprise. Things like business impact, regulatory compliance, or operational severity. The third one is naive cluster-based labeling is risky. Errors at the cluster level get multiplied across your entire training set. So, and here's the critical gap. To the best of our knowledge, no prior work combines all three elements: clustering, assisted semi-supervised labeling, expert validation, and decoupled severity and priority prediction in a single industry-oriented framework. So let me now outline the four objectives that drew our research. Our research had four clear objectives. First one is we wanted to build a real industrial data set, not scraped from public repositories, but purpose-built with 16 carefully chosen features that reflect now bugs actually impact a business. The second one is we designed a semi-supervised framework that combines k-means clustering with expert-guided labeling and significantly reduces the manual annotation burden. The third one is we trained separate independent classifiers for severity and priority. And the fourth one is we aimed to exceed 90% accuracy on both tasks. And I'm pleased to say we achieved that. Now let me walk you through the exact how we built this framework. The pipeline has 8 stages. We start by collecting 2,000 UI bugs reports from industrial environment, and then we organize the data around selected feature attributes. We split the data into training and test sets before any clustering happens. This prevents data leakage, where the knowledge from the test set could influence how clusters are formed. We then apply k-means clustering exclusively on the training set. Within each cluster, domain experts manually label a representative sample of instances. Those expert labels are then propagated to the rest of the training data using a majority vote mechanism. So then the test set, on the other hand, is independently and fully labeled by experts, giving us a clean, unbiased ground truth for evaluation. So finally, we train and tune our models using cross-validation. Our expert panel consists of 8 experts. After that, let me now explain the features we could represent each bug, data set and feature engineering, please. So one of the distinguishing aspects of this work is our feature set. Most public datasets only capture textual or code level attributes. We went further. Our 16 features span 4 dimensions. Functional features describe what the bug affects. It means category relevant field, whether it's tied into a new feature. So then operational features capture how the bug behaves in the real world, how often it occurs, how easy to reproduce, whether a workaround exists, likewise. And business and compliance features are often entirely absent from the public data sets, things like regulatory impact and customer-facing consequences, likewise. And finally, effort and complexity features estimate the cost of fixing the bug, development effort, dependencies, and fixed time ranges. So we deliberately excluded administrative fields like issue IDs and reporter names. Next, now, how does the system actually work in the practice? System architecture and design. The system design is straightforward and practical. A user submits a test case through command line interface that input goes to Python backend, which runs it into Selenium and simulate real execution. If the test fails, the system collects relevant feature values and feeds them into two independent machine learning models, one for severity and one for priority. For the implementation stack, we used Google Colab model training, PyCharm for local development, scikit-learn for all classifiers, and joblib to serialize the trained models into deployable files. The architecture is intentionally lightweight, designed to be deployable in real engineering workflows without requiring a specialized infrastructure. So let's look into how the models actually performed. Cross-validation performance. We evaluated 7 classifiers using 5-fold cross-validation, logistic regression, KNN, SVM, random forest, gradient boosting, naive bias, and XGBoost. The results were strong across the board. For priority prediction, SVM, random forest, gradient boosting, and naive bias all achieved a mean accuracy of 90%. For severity, SVM, gradient boosting, and naive bias reached 90% as well. But what I find most compelling is standard deviation. It just 0.01 across all classifiers and all folds. That tells us the framework is genuinely stable and the model generalizes well. Then results, the final model evaluation, please. On the independently expert label test set, the results held up very well. For severity prediction, SVM, gradient boosting, and naive bias all achieved 90% 5 accuracy. For priority prediction, SVM, gradient boosting, and naive bias reached 92.25 accuracy. Precision and F1 score were aligned with accuracy in both cases, which confirms there's no hidden trade-off going on. So these 3 numbers summarize the contribution: 92.25 best priority accuracy, 90% 5 best severity accuracy, and a standard deviation of just 0.01. Consistently stable performance. So how does this compare to what's already out there? The comparison with existing works. Every prior method we reviewed, they all depend on a fully supervised labeling. They all have limitations, heavy annotation requirements, reliance on public data sets, no industrial specific features, or binary only classification. So our framework here is the first to combine clustering assisted semi-supervised labeling with expert validation and decoupled classifiers for both severity and priority in one unified framework designed specifically for an industrial context. So let me now bring this all together with our conclusion. To summarize, we introduce a scalable semi-supervised framework that meaningfully reduces manual annotation effort while maintaining high predictive accuracy. We built an industrial data set with 2,000 bug reports with 16 features designed specifically to capture business and operational dimensions that matter in enterprise environments. By decoupling severity and priority classifiers, we eliminated the interdependence bias that often affects joint models. SVM delivered strongest results, and by restricting clustering entirely on the training set, we preserved experimental integrity. Finally, user feedback from domain experts confirmed that the system is practically useful, economically sound, and trusted by practitioners who actually work with bug reports every day. And then the limitations. To be transparent, the dataset, while industrial, comes from a single domain. This means the model may not generalize directly to very different project types without retraining. We also prioritize interpretability and structured features of deep NLP techniques, which means there's a headroom for improvement on unstructured tests. So these are known as trade-offs we made deliberately, and they point directly to our future work. So next, moving to the future work, looking ahead, we see four key directions. We plan to expand the framework beyond UI bugs to cover server-side database and API defects. We'll integrate the deep NLP embeddings like BERT and sentence transformers to better handle unstructured bug descriptions. We also exploring intelligent developer assignment, where the system not only predicts severity and priority, but recommends who should handle the fix. And ultimately, we aim to close the loop with automated test case generation. Then the references, the key references supporting this work are listed here. I particularly draw your attention to the publicly available data set. And next one. Thank you very much for your attention, and we are happy to take any questions.
Thank you, ma'am, for the presentation. I have no questions.
Thank you for your presentation.
Thank you.
And with that, we have concluded all the sessions for today. I sincerely thank all the authors for the excellent presentations and valuable contribution to this conference. I also extend my gratitude to all participants for being a part of this conference. I hope this session has been informative and enriching. On behalf of the organizing team, thank you for your continued support for ICTIS over the years. We look forward to welcoming you again at the 12th edition in 2027. All presenters will receive their digital certificates via email within 2 working days. And the publication process will be completed within 7 to 8 months. So kindly extend your cooperation to the ICTIS 2026 team during this process. I would also like to thank our session chairs for effectively chairing this session. Dr. Murad Aydin and Vidula Mishram. And as a token of appreciation, we present this certificate to you. Dr. Aydin, would you like to say a few words?
And I would like to thank all presenters for sharing their innovative research today. And we explored a wide spectrum of topics. And I would like to thank to organizers and thank to you and my co-chair, Dr. Vidula Meshram, for the support. Thank you all for your participation.
Thank you, sir. Professor Vidula, would you like to share any closing remarks?
Yes, ma'am. So first of all, thank you to you for nicely coordinating the session. And presenters for presenting it, Mr. Murat Aydin, and thank you so much.
Thank you for your kind words, ma'am. At last, I request everyone to please turn on the camera so that we can have a quick snapshot of the session. Thank you everyone for joining us today. Have a great day.
Thank you.
Thank you.
Thank you.
Thank you. Thank you.